Thank you, Guglielmo, for inviting me here. Discuss a very interesting paper. I'm probably one of a few guys in financial economics who get excited about identification issues, about the spurious factors, useless factor problem. Typical reaction that we get from the finance audience is that the model is not identified. You know what you should do? You should just change the set of test assets so that maybe it becomes identified. You know, it seems extreme, but this is what sometimes we get as comments. And you know, as econometricians, we are given a set of assets, and it's not clear that if we change the set of test assets, we are going to get different conclusions. So I hope Enrique convinced you that this is a very serious problem, and I will try to put Enrico's presentation into a framework and see how, you know, what has been done, what still needs to be done, and so on. It's a very nice paper. So I'm going to start with the setup and the literature review. I'm going to proceed with some comments that, you know, Enrique has already taken care of, probably. You know, in the last few weeks, they've done quite a bit of work. And then I'm going to show some directions for future research. This is the setup. So we basically start from below one price, nothing else. We are not imposing positivity of the SDF. Okay? Imposing positivity, if one thinks that the problems may go away, problems don't go away. They stay there, even if we assume absence of arbitrage. So we start from the simple low one price applied to this vector RT, which is a vector of excess returns, has a dimension of n. N is the number of test assets. And basically, we say, well, there are many potentially admissible SDFs. The only thing we can do is to work with some candidate SDFs, and we assume that these candidate SDFs are linear in a set of observable risk factors denoted by FT. And we call the theta vector AB, basically the intercept and the coefficient, the slope coefficient associated with the risk factors. So if B is different than 0, this is evidence in favor of the fact that the risk factor is priced. Okay? If you think about the two-pass methodology, the beta pricing methodology, there you would have the so-called gamma being different than 0, evidence that the risk premium on the observable factor is different than 0. But here we are in the SDF framework, and of course we can map this again into the beta pricing framework. The problem would also persist there, would not be eliminated. So the pricing relation can be rewritten using Enrique's terminology as m theta while equal to 0n. M is this matrix, which is n times k plus 1, and it consists of E of RT, the expected returns, and the cross product between the excess returns and the factors. So rank m equal to k is, as Enrique said, the usual identification condition required for standard GMM inference. Of course, if we have k plus 1, then there would be no model compatible with the asset pricing restrictions. In this regard, maybe I have just some semantics, but basically, Enrique, what he does is to look at the subspace of all these risk prices which are compatible with the asset pricing restrictions. But as he said, you can also have SDFs which do not satisfy the asset pricing relation, right? So the model can be misspecified. And for example, this SDF, if you think about a one-factor SDF, may contain a spurious factor. In this case, we will still have that the rank of M is equal to K, right? Because the model is misspecified, so the null subspace will be equal to K. Now, should we call this model identified? In some sense, it is. So in Enrique's terminology, when D is equal to 1, the model is identified, right? In some sense. We can always identify, in some sense, a subspace of this parameter vector, which is consistent with the asset price restrictions, and then we can basically continue with standard GMM. Now, the question becomes, is a model misspecified, but with a spurious factor, a model which is identified? Is the coefficient on the spurious factor identified? This becomes more a matter, maybe, of semantics, okay? So basically, what Enrique says in the paper and this is very consistent with what also we do, is that when the rank of M is smaller than K, then we lose identification. And this is what Aureliano, Hansen, and Santana call under-identification, okay? So I like the paper because it's the first paper in the literature really focusing on set identification as opposed to point identification. Think about what has been done in the literature and the correctly specified model. Think about, for example, Stoker-Wright 2000. Think about Andrews and Chen 2012. They really talk about point identification, okay? So they provide a quite general theory under the correctly specified model when part of a parameter vector is weakly identified or unidentified. But this is one of the first papers, if not the first, to my knowledge, enough surprising at least, to work with set identification. And he connects it, right? All this set identification is connected to reduced rank asset pricing models, right? So Enrique talked, for example, about this null subspace, what can cause basically this null subspace to be of different dimensions, and this is connected to the covariance between the accessory terms and the factors, right, being the efficient rank. So the main idea of the paper is to work on the dimension, denoted by D, of the subspace of solution to the asset pricing restriction and consider D up to K, okay? Or M with rank as low as 1. When D is equal to 1, you can use standard GMM to estimate a unique theta, of course up to normalization. When D is greater or equal than 2, we have a multidimensional subspace of admissible SDFs even after fixing the scale. And we have to estimate the basis of that subspace by replicating D times the moment conditions 2, right, the asset pricing restrictions, and imposing enough normalization on the parameter vector to ensure identification of a basis. Okay? And then Eric also showed how to add a set of equations for the mean. Now, what has been done? Kahn and Zhang basically deal with two frameworks, SDF and 2PAS, or SDF and beta pricing frameworks, and they introduce the idea of useless factor. And they look at the consequences for point estimates and the t-statistics of this identification failure caused by the presence of one useless factor in the analysis. As I said before, Stoker-Wright and Andrews and Chen provide a very general framework with weakly identified or unidentified parameters under the assumption that the models are correctly specified. In recent work, we extend a little bit Stoker-Wright and Andrews and Chen even under the assumption that the model is correctly specified. Their framework, as we show in some of our work, cannot really deal with some complicated situations that arise when the mean, for example, of a spurious factor is different than 0 or is 0. So in that case, you have basically very different limiting behaviors for the parameter estimates for the t-statistics. Then two recent papers, Kleibergen and Zahn, they look at beta pricing setup only, and they look at robust statistics from the borrowed in some sense from the Ivy literature, and they do analysis, especially Kleibergen 2009, under correctly specified model and under misspecified models. Again, all this is some sense for point estimates and for a measure of statistical significance. Two papers with Nikolai Gospodinov and Raymond Kahn, 2014, where I look at the SDF HA distance type estimators. And then I have a paper now on the CU-GMM estimator, and we look at the SDF and beta pricing setups. We propose in both papers a sequential procedure, which is based on misspecification robust standard errors to restore standard inference. And I will connect this to what Enrique is doing in his paper. Then we have two papers by Burnside, 2011 and 2014. And in the 2014 version, Burnside is proposing a sequential rank procedure to get rid of, in some sense, factors that cause identification failure. Okay, he has this new version. And then, to my knowledge, there are two more attempts. And one is Brizgalova, who is here at LSE in London. She's doing some very good work. She's using the lasso to augment this 2PAS cross-sectional regression framework with some penalty term. And this lasso framework, she shows, restores a standard inference. And then there is a paper by Kalaf and Schaller, and they use artificial regressions in a 2PAS framework again in order to take care of a spurious factor problem. This is all the literature I know, at least in asset pricing. that looks at spurious factors. I would say that the closest paper to Maresa, Penaranda, and Santana is our paper of 2015. Two common features. One is that we also look at CUGMM. The other one is that we also look at the multidimensional subspace, although we use the null subspace, so we look at the correctly specified model, misspecified models, mostly for inference purposes, so we do pointed estimation. This is one picture from our paper, and it shows how the problem can be very serious. This is basically plotting the limiting distribution of the t-statistics on the useless factor in a model with a useless factor and some other, let's say, relevant factors. And so you see that if you compare the t-statistics, the square t, right, with I square 1, you would make a very big mistake because when the factor is spurious, we have this bimodal behavior of the limiting densities. The problem is serious when the model is correctly specified. It becomes even more serious when the model is misspecified. And this would be the behavior of specification test, CUGMM specification test for different dimensions of a null subspace. The R here would be the D in Enrique's terminology for different. These results don't depend on whether the model is correct or not. It just depends on whether there is on the dimension of a null subspace. So this said, I think it's a very nice paper on admissible SDFs. It has a lot of stuff. It has J-tests. It has distance matrix tests. I would provide, for the reader like me, some description of this distance matrix test. I'm not very familiar. I think I understand how you restrict maybe the CUGMM objective function. You don't restrict it, but it would be very nice. And report standard errors. Okay? So the questions, I have some questions. Are the reported standard errors, the p-values of a distance matrix test, valid under identification failure? So suppose that you do not reject a null subspace of dimension equal to 2. So when you have a dimension equal to 1, the reported standard errors, I'm not sure they are valid, because it is true that you don't reject the model, so you can use traditional standard errors, but there would be identification failure there. So some of the factors, so maybe not reporting those standard errors would be better, or explain how distance matrix tests and standard errors are correct, because as we saw before, there is problems in point identification there. So one result, and is not the model that Enrique presented to you, but is the other model in the paper, which is Veletau and Ludvigson. So in that case, we cannot reject a three-dimensional subspace. So the analysis implies that SDF linear in chi, or in non-durables, or in the interaction term, can explain the cross-sectional variation equity returns. This is kind of puzzling, right? So an SDF linear in chi. Does this mean that an SDF, I mean, looking at the d equal to 3 case, linear in chi explains the cross-section exactly? So in this case, I would like also to see maybe rank test some correlations, see what is happening. Of course, now you have also changed the number of test assets. Before you were using 6, now you're using 25, so things can change, of course, based on the number of test assets, but it would be interesting to see that. And one of my questions is how feasible it is to use a large number of assets. In the previous version of the paper, there were 6 assets. Now, the number of degrees of freedom increases exponentially. It's not linear in the number, right, in the dimension of the null subspace. So how feasible is this? And I'm going to connect this to final sample properties of a test. So I think that it's a very nice paper. It's a lot of information. I think that the reader would definitely benefit from providing a flowchart. So what we look at if we want to proceed. We start with d equal to 1, we go to d equal to 2, d equal to 3. Do we propose, how do we read the distance matrix test? Sometimes there are inconsistency between the distance matrix test and the standard error, for example, of the estimates. How do we interpret that? So I think we would benefit as readers from having a flowchart there. I'm not going to spend time really on this. This is more my way of looking at the problem. So either you go as Enrique goes and you say, okay, let's just plot out all the possible dimensions of a null subspace, or you could proceed in the following way. Suppose that the model is rejected. If the model is rejected, either you stop there, or if somebody is interested in doing inference under misspecified models, can use a misspecification robust standard errors, like in White if you do MLE, or you can do basically, Holland Inouye and other people. I know this is not the way Enrique would follow, but one could also stop. You reject the model, you just stop there. You throw it away. It's a bad model. The problem is, what Enrique was trying to convince you about, is that when you don't reject the model, it's not necessarily because it's a good model. It could be a very bad model. At that point, one thing that you could do, you have to test whether the model is misspecified, for example, and has a spurious factors. You have to provide a test of this type of situation. If you don't reject, well, you can stop there, or you can do model selection as we proposed using misspecification or bias. If you reject, this means that you are in the case of correctly specified models with potentially spurious factors. At this point, you could use, for example, you would be exactly in the framework of Anderson, Chen, and Stock and Wright. And you could try to do model selection using the methodology of Burnside, which is based on sequential rank testing. One thing that I want to say, your methodology can definitely detect non-trivial SDFs. It is true, if we just stop with our papers, in our papers at the rank test, then we cannot. But I think that the Burnside's methodology, and in some sense our methodology based on misspecification robustity ratios, is going in this similar direction, which is trying basically to throw away the factors or linear combination of the factors that cause identification failure. Okay, so we are not that different in spirit. It is very different methodology, and your perspective is probably more insightful in the sense that basically it gives us all the possible SDFs. We would end up with one at best. Over-specified models. One question, there is some tension here. I'm not sure whether, in terms of selling the paper, I would basically go with these over-specified models. One comment that I often receive is the following. The asset pricing specifications are often dictated by theory. So, for example, the Yogo model contains 3 factors, but these 3 factors should be there. Theory says should be there. So, if we call them over-specified in some sense, what we are basically saying, we are talking as econometricians. And of course, these models, as they are, embed some sort of identification failure. But I'm not sure that the best way to say the model is over-specified. The model is what it is. And then we have to find a way to get rid of a problem that we encounter when we want to estimate and test these models. So one question that I have, and is exactly because of the fact that we are replicating moment conditions, right? When we look at the null subspace, and we basically have it equal to 3 or equal to 4 or equal to 5, then we end up having a lot of a very large n. And we know, I mean, from, for example, some work that I have done, but also other people have done, when n is 25 or higher and k is 3 or higher, using the traditional CUGMM standard errors will lead to strong over-rejection under the null. Okay, so we have a recent paper on basically looking at misspecification robust standard errors for MLE and CUGMM, in which we find huge over-rejections, at least for parameter testing. So I think that we need to make sure that also, by replicating this set of moment conditions, we don't end up also having some poor final sample properties. And in some cases, the t-statistics in the paper are very large. This may not be very indicative. Another thing that I would like to see in this framework, and is just curiosity, I could do it, but is this analysis of a liquidity augmented CAPM. So we show in some appendices of our papers that a CAPM augmented with liquidity risk is subject to identification failure. So the heralded liquidity factor of Stambag, Pastor Stambag or Liu 2006, may work, but individually these factors are useful, but linear combination of them basically become kind of useless and causes identification failure. And then analysis for gross returns, of course, Enrique has done it. And maybe for the appendix, I think that you are choosing a different normalization, so and so on. But so the point becomes, the questions are, it's still open questions, right? Because this is not an easy problem. People may think, well, we can easily identify the spurious factors and throw them away. It's not that easy. But so it becomes, how can we detect in a reliable way spurious factors? How can we robustify inference against the presence of spurious factors? And then I think that CUGMM is just one member of a class of GL. My suspicion, and I've never done work besides UGMM, but also other members of a GL family are subject to the same type of problem, like, for example, empirical likelihood or maximum entropy and so on. And then I think that another interesting direction would be to go to nonlinear models. So my feeling is that many of the problems that we see for linear models still carry to nonlinear models. So we have, at that point, it's more difficult to think in some sense about correlations and about useless factors and so on. But I think that in this case, one may work just on the Jacobian and see if some of the conclusions for linear models also apply to nonlinear models. I conclude here. It's a very nice paper. It's the first paper that does set identification, and I learned a lot by reading it.